Hello learners, I welcome you all to the online course on electricity and electrical wiring. I am Dr. Shankar Moni Bora from the Department of Applied Sciences, Guwahati University, Guwahati, Assam. Today we will be starting Module 5, which is on electrical measurement and instruments. This module is divided into 3 sessions. So, learners, in this session, we are going to discuss about the measurement devices, which will be the first part and which are of vital tools for working with electricity. These devices help to accurately assess electrical parameters and ensure safe and effective operation of various electrical systems. In today's topic, we will focus on first, the importance of electrical measuring devices, then analog multimeter, its working principle, then the digital multimeter and the working principle of the digital multimeter. Then we will touch upon the principle of operation of the multimeter. Then we will talk about the accuracy of measurement of the multimeter. Then next topic will be on tongue tester, which will be followed by the energy meter, the Megger, the earth resistance meter, and finally the watt meter. The learning objectives of this chapter are to provide the basic concept of electrical wiring, to discuss the importance of electrical wiring, to familiarize with different types of multimeter, to understand the working principle of the multimeter, and to get an idea of the different electrical wiring instruments. Now, coming to the first topic, which is the importance of electrical measuring devices. Electrical wiring is important for many reasons like safety, energy efficiency, and cost savings. Proper wiring will help to prevent electrical shocks, short circuits, and fires. Now let us understand a little bit about the analog multimeter. A multimeter is a flexible instrument which can measure a variety of electrical components like voltage, current, resistance, and continuity. Using this instrument, you can detect electrical faults, troubleshoot circuits, and take accurate readings. It is used to measure the 3 fundamental electrical properties of voltage, current, and resistance. It may also be used to access the continuity between locations in an electrical circuit. A multimeter may be used for checking batteries, home wiring, electric motors, and power supply. Let us now discuss about the working principle of the analog multimeter. An analog multimeter, or abbreviated form known as VOM, which stands for volt ohm milliammeter, uses a moving coil meter and a pointer to show readings on the scale. The moving coil meter consists of a coil wound around a drum which is positioned between 2 permanent magnets. As current runs through the coil, magnetic field is created in the coil which interacts with the magnetic field of the permanent magnets, and the resulting force causes the pointer attached to the drum to deflect on the scale, thereby indicating the current reading. It also includes springs attached to the drum which provide an opposing force to the motion of the drum to control the pointer deflection. D'Arsonval movement is applied for the measurement of direct current, which is abbreviated as DC. But the current to be measured must be smaller than the full-scale deflection current of the multimeter. Now, for the measurement of the DC voltage, a resistor is connected in series with the multimeter and its resistance is taken into consideration so that the current passing through the resistor is same as the current through the multimeter, and the total reading shows the voltage reading. For voltage measurement, the instrument is connected in parallel with the unknown voltage source. For measurements of different ranges, various resistors of varying values should be used, which are linked in series with the multimeter. Now, for resistance measurement, the linked series with the multimeter across a battery so that the current passing through the multimeter is proportional to the unknown resistance. Similarly, alternating current, which is abbreviated as AC, or voltage measurement is done in the same way, except for the fact that the AC component to be measured is first rectified and then filtered to get its equivalent DC component, and the multimeter provides the root mean square known as the RMS value of the AC signal. The main advantage of an analog multimeter are that it is cost effective, does not require a battery, and it can monitor changes in the readings. The two important parameters impacting its measurement are sensitivity relating to the opposite of the full-scale deflection current being measured in ohms per volt and accuracy. Now let us study about digital multimeters. A digital multimeter, abbreviated as DMM, is used to measure and perform all operations from AC to DC other than analog. It consists of two probes, positive and negative, denoted with black and red color. The black probe is generally linked to the common jack, and the red probe is linked as per requirement to measure resistance, voltage, or current. The next topic that we will be discussing is the working principle of digital multimeter. DMM comprises an LCD, a knob to choose different ranges of the three electrical properties, an internal circuit consisting of signal, and an analog to digital converter. The PCB consists of concentric rings which are linked or detached depending on the position of the knob. When the required parameter and the range are chosen, the part of the PCB is triggered to do the relevant measurement. The resistance is measured when current flows from a steady current source through the unknown resistor, and the voltage across the resistor is amplified and is sent to an analog to digital converter. The resulting output in the form of resistance is then shown on the digital display. To measure an unknown AC value, the voltage is first reduced to gain the correct range and then rectified to a DC signal, and the analog DC signal is supplied to an analog to digital converter to produce the display, which displays the RMS value of the signal. To measure an AC or DC, the unknown input is first transformed into a voltage signal and then supplied to an analog to digital converter to acquire the required output, with the rectification in case of an AC signal. Now, the advantages of a digital multimeter include its output display, which quickly shows the measured value, remarkable accuracy, and ability to read both positive and negative values. There are different types of digital multimeters. Some of them will now be discussed. The first one is the Fluke multimeter. The Fluke digital multimeter consists of a number of collective functionalities. It consists of a big display, and this device is used to measure the voltage and the electrical resistance. Some of these multimeters are provided with broad functions to measure humidity, duty cycle, pressure, frequency, and temperature. It is mostly used for calibration purposes and used to calibrate currents, voltages, and other electrical units. The next digital multimeter that we will study is the clamped digital multimeter. The clamped digital multimeter is used to measure the electric flow in an instrument. It has a clamp that measures the currents when the probe senses the voltages. It also has an additional function which does various sorts of settings, and the appropriate feature is applied during the measuring. It has fixed equipment for measuring the current flow. The third digital multimeter is the auto-ranging multimeter. This multimeter is an uncomplicated multimeter to use, although it is most expensive of all the types of digital multimeters. This multimeter contains a knob in the middle and has less position, so it does not switch automatically to record the measurement. This instrument is suitable for basic measurement purposes. For beginners as well as electricians at home, this gadget is the most appropriate. Generally, it measures one component at a time. Now let us discuss the principle of operation of multimeter. The basic principle of a multimeter is to use a sensitive magnetoelectric DC emitter, microemitter, as the meter head. When a small current passes through the meter, there will be a current indication, but it cannot pass large currents. In order to overcome this limitation, some resistors in parallel and series are connected to the meter head to shunt or step down to measure the current, voltage, and resistance in the circuit. The following methods are applied for measuring different parameters in an electrical circuit. Number 1, the principle of measuring DC current. An appropriate resistor, which is called a shunt resistor, is connected in parallel to the meter for shunting, and the current range is increased. By changing the resistance of the shunt resistor, the current measurement range can also be changed. The second principle is the principle of measuring the DC voltage. An appropriate resistor, which is also called multiplier resistor, is connected in series with the meter to step down the voltage, and the voltage range gets increased. By changing the resistance value of the multiplier resistor, the measuring range of the voltage can be changed also. The third principle is the principle of measuring AC voltage. Since the meter head is a direct current meter, when measuring alternating current, a parallel and series half-wave rectifier circuit has to be connected to rectify the AC into DC and then pass the meter head, so that the AC voltage can be measured according to the size of the DC power. The method of increasing the AC voltage range is similar to that of the DC voltage range. Number 4 is the principle of resistance measurement. For measuring resistance, appropriate resistors in parallel and in series are to be connected with the meter head, including a battery in series at the same time, so that the current flows through the resistor under test and the resistance value can be measured according to the magnitude of the current. By changing the resistance value of the shunt resistor, one can easily change the range of the resistance. Now, coming to the next topic, which is the accuracy of measurement of multimeter. So, the digital multimeter generally defines accuracy as a percentage of reading plus a percentage of full scale value. Accuracy depends upon the specifications of the instrument and it varies from manufacturer to manufacturer. There are a number of ways in which the multimeter accuracy may be expressed. And one of the general methods used is that the DMM accuracy will be equal to the ppm of the reading plus the ppm of the range. Then another method used is the DMM accuracy will be equal to the percentage reading plus the percentage range. The third method of accuracy measurement will be DMM accuracy is equal to the percentage reading plus offset. In all the three cases, PMM refers to parts per million. The accuracy of multimeter is influenced by the following factors. Number 1, temperature. The surrounding temperature can affect the accuracy of digital multimeters. As such, many multimeters have an inbuilt temperature feature which eliminates the need for an external device. It is represented as ppm of reading plus the ppm of range per degree centigrade. Number 2 is the resolution. Resolution is directly proportional to accuracy. The resolution is expressed in terms of the number of digits displayed. Generally, this will be a number consisting of an integer and a half, that is 3.5 digits, etc. By convention, a half digit can display either a 0 or 1. So, dear learners, let us now do a self-check of our learning so far by attempting the following questions. So hope you have attempted the quiz questions, and now we will go ahead to learn about some useful electrical wiring instrument. The first such instrument that we will learn is the tongue tester. Schematic diagram of the instrument is being shown. Now, a tongue tester is an electrical test instrument or device which measures current without being connected to the circuit, and it works on the principle of mutual inductance similar to that of a transformer. It is also known as clamp meter. It has an integral AC current clamp with jaws which open to allow clamping around an electrical conductor. The clip or clamp or moving part of the meter contains a magnet in it which acts as a magnetic core. A coil is wound over the core and it acts as a secondary coil. The device primarily detects the magnetic field emitted by the current flowing in the conductor to measure the current value. This allows measurement of the magnitude of the current in a conductor without the need to make any physical contact with it or to disconnect it for insertion through the probe. This instrument is used to measure the vector sum of currents which flows in all the conductors passing through the probe, and it depends on the phase relationship of the currents. The design of this device has the advantage of being able to measure current without requiring the circuit under measurement be cut. The second instrument which we will now discuss is the energy meter. A picture of the energy meter is shown for your understanding. The energy meter is a device which is used to measure the energy which is utilized by the electric load. The energy is the total power consumed and utilized by the load at a particular interval of time. It is used in domestic and industrial AC circuit for measuring the power consumption. The meter is less expensive and is accurate. The energy meter has four main parts, which are: number one, the electromagnet is the main component of the driving system. It is the temporary magnet which is excited by the current flow through its coil. The coil of the electromagnet is made up of silicon steel lamination. The driving system has two electromagnets. The upper one is called the shunt electromagnet and the lower one is called the series electromagnet. The series electromagnet is excited by the load current flow through the current coil. The coil of the shunt electromagnet is directly connected with the supply, and so it carries the current proportional to the shunt voltage. This coil is called the pressure coil. The center limb of the magnet has the copper band. These bands are adjustable, and the main function of the copper band is to align the flux produced by the shunt magnet in such a way that it is exactly perpendicular to the supplied voltage. The second part is the moving system. The moving system is the aluminum disc which is mounted on the shaft of the alloy. The disc is placed in the air gap of the two electromagnets. The eddy current is induced in the disc because of the change of the magnetic field. This eddy current is cut by the magnetic current, and the interaction of the flux in the disc induces the deflecting torque. When the device consumes power, the aluminum disc starts rotating, and after some number of rotations, the disc displays the unit used by the load. The number of rotations of the disc is counted at particular intervals of time. The disc measures the power consumption in kilowatt hour, which is expressed as kWh. Third is the braking system. The permanent magnet, which is used for reducing the rotation of the aluminum disc. And the aluminum disc induces the eddy current because of their rotation. The eddy current cuts the magnetic flux of the permanent magnet and thereby produces the braking torque. This braking torque opposes the movement of the disc, which reduces their speed. The permanent magnet is adjustable, due to which the braking torque is also adjusted by shifting the magnet to the other radial position. Now, number 4 is the registration or the counting mechanism. The main function of the counting mechanism is to record the number of rotations of the aluminum disc. Their rotation is directly proportional to the energy consumed by the loads in kilowatt hour. The rotation of the disc is transmitted to the pointers of the different dial for recording the different readings. The reading in kilowatt hour is obtained by multiplying the number of rotations of the disc with the meter constant. The construction of the single phase energy meter is shown in the figure below. The next instrument that we will be learning today is the Megger. Dear students, you can see a figure of this instrument in this screen. Now, a Megger is a type of an electrical test instrument which is used to measure the insulation resistance. This equipment applies a high voltage to the circuit and it measures the amount of current that flows through the insulation in that circuit. This helps to identify potential problems with the insulation, such as damage or degradation. It works on the principle of electromagnetic attraction. The insulation with low resistance is tested using a steady voltage. A Megger consists of an electromotive force source and voltmeter. The scale of the voltmeter is calibrated in either ohms, kilo ohms, or mega ohms depending on the degree of insulation in the circuit. During measurements, the electromotive force of the self-contained source must be equal to that of the source used in calibration. Generally, insulation tests using this device are performed at a DC voltage of 1000 volts for 600 volt rated equipment and at a DC voltage of 500 volts for 120 to 130 volts rated equipment. For high volt rated equipment, test is usually performed at a DC voltage of 2500 volts. Now, the continuity checks are to be performed with a low voltage DC meter. In this device, the magnetic field which is generated between the two poles of the permanent magnet is used to rotate the rotor of the DC generator by using the crank handle, resulting in the generation of some voltage and current. This current generally flows in an anti-clockwise direction through the coil. The next instrument that we'll be studying is the arc resistance meter, and a picture of this instrument is being shown in this screen. The arc resistance meter is an instrument which is used to measure the resistance of the arc and detect any faults in the grounding system. It is also known as ground resistance meter or as arc tester. This instrument is used to measure the lightning arresters or ground connection lightning arresters for all type of buildings with a high degree of accuracy. In this device, both the pressure and the current coils have two terminals each. These pairs are placed across a permanent magnet. One synchronized pair of current and pressure coils are short-circuited and are connected to the ancillary electrodes. The other pressure coil is connected to the rectifier at one end and to an earthing electrode at the other end. The current coil is also connected in a similar manner. The potential coil is united to the DC generator without any deviation. The potential coil is placed within the permanent magnet. The coil is connected to the pointer and the pointer is calibrated to the scale. This resistance pointer indicates the measurement of the arc's resistance. The deflection of the pointer depends on the quotient of the voltage of the pressure coil to the current of the current coil. The short circuit transfers the current to the ground. Therefore, the resistance is measured using Ohm's law, which is as follows. V is equal to I into R, where V is voltage, I is the current, and R is the resistance. All the components of the system are grounded through the earth electrode. Unrestricted earthing helps in protecting both the electrical equipment from damage and the user from the fault current which passes to the earth. Another instrument which is of importance is the wattmeter. We will be discussing about this instrument in this section. A picture of the wattmeter is shown in this screen. The wattmeter is an instrument which is used for measuring the electric active power or the average of the rate of the flow of electrical energy in watts of any electrical circuit. Electromagnetic wattmeter is used for measurement of utility frequency and audio frequency power, but it cannot measure radio frequency measurements, for which other type of wattmeter is used. This device measures the sampling currents and voltages several thousand times per second. The obtained values are sampled and multiplied by one another to determine a wattage reading at any given time. There are two standard types of wattmeter. Number one is the analog wattmeter and second is the digital wattmeter. A picture of the analog wattmeter is shown in this screen. Analog wattmeter was broadly used for decades and consists of a pointer that actions over a scale to suggest strength intake. It generally consists of a contemporary coil and a capability coil which produce magnetic fields proportional to the present day and voltage inside the circuit. The interplay of those magnetic fields causes the pointer to move, offering a visible representation of the power. The next wattmeter that will be discussed is the digital wattmeter, a picture of which is shown in this screen. Now, digital wattmeter is used in present day due to its precision and ease of use. This device uses digital presentations to offer energy readings as it should be. It can degree each lively and reactive power, supplying an extra comprehensive evaluation of the electrical system. Dear learners, as we have come to the end of the discussion on multimeters and different types of electrical wiring instruments, let us now test our learning by attempting the following questions. So learners, in today's session, we have discussed about the basic concepts on electrical wiring. Then we have discussed about the multimeter instrument and its different variations. At the end, we have discussed about some of the electrical wiring related devices like tongue tester, Megger, arc resistance meter, and the watt meter. In the next session, we will focus on the electronic voltmeter and ammeter respectively. I hope the information given in this video would help you to enhance your knowledge about electrical wiring. Thank you very much.